Good evening, guys. I'm Vasudev. I welcome you all for AICUT Prerna sponsored for the SEST students organized by Ballapur Institute of Technology. Today we are going to see our third session, and in today's session we will be seeing on the topic of permutations, combinations, and probability. So, can you guys give me an idea of what is permutations, combinations, and probability? Because this topic we would have already seen from our school times. Yes, guys. So, before getting into permutations, combinations, and probability, into that topic, we will be going for a small another topic called as fundamentals of computing principle, counting principle. Yeah. So in this, for example, I'm directly giving you a question. Please try to read it and understand this question and try to answer the questions asked below. In a shopping mall, has three distinct glass doors and two distinct metal doors for entry and has five distinct glass doors and a wooden door for exit. In how many ways can you enter the mall? So to enter the mall, what is happening is like I have three distinct glass doors and two distinct metal doors. So whenever they were asking such question, so through this three glass doors, I can enter three ways. Through this two distinct metal doors, I can enter in two ways. And whenever they have a term called as and, for this and we will be using addition of this values. So in such case, in how many ways I can enter a mall? So 3 plus 2, totally 5 ways I can enter the mall. And in the second case, so I can enter the mall in five distinct glass doors. And has five distinct glass doors and a wooden door for exit. So what is my next question? In how many ways can you leave the mall? So leaving the mall, so in that case it is like five distinct glass doors and here a wooden door. So here also we have used a term called as and either this five distinct glass doors or this and a wooden door is a possibility. So in that case we'll be keeping it as unconditioned. So unconditioned means we will be always adding between the values. So it is like 5 plus 1, in 6 ways I can leave the mall. And try to answer the next one, guys. And in total, how many ways can you enter and leave the mall? So enter and leave the mall. So how many ways can you make entry? So entry for the mall can be made in five different ways. In how many ways you can exit? Sorry guys, I just came up with a small error. Yeah. So actually, the point is, I can enter the mall in using this three distinct glass doors or this two distinct metal doors. So we are saying it as or condition there. So R condition means we'll be trying to add in between this. So here also it is like five distinct glass doors and a a wooden door. So in that case also it is like either I can enter the mall, exit the mall in five distinct glass doors and a wooden door. So there are also R conditions. So R conditions means we will be adding in between that, and in this case entry and exit. So I have to make entry in five distinct ways, and six exits are possible, six ways of exit. So entry and exit. So entry and exit means it is going to be like unconditioned. So whenever unconditioned comes, we will be always multiplying between this uh, thing. So it is like 30 different ways I can enter and exit the mall. Yeah. So whenever it is an or condition comes, we will be adding between the values. So whenever unconditioned comes, we will be multiplying in between the values. Yeah. Sorry for the initial confusion. And try this question, guys. So what they were saying in this question, if there are three trains from A to B and five trains from B to C, so in how many ways can one travel from A to C by train? Assume there are no direct trains from A to C. So how can he travel? So first he has to move from A to B, and then only he can move from B to C. So they were asking for how many ways they can travel from A to C. So in that case, A to B possibility is like three trains are there, and from B to C it is like five trains. So we try to multiply in between this because uncondition is being used. So in such case, we will be getting it as 15 different ways they can reach from A to C. Yeah, hope you guys are getting this. And moving on for permutations and combinations now. So before getting into the what is permutation and what is combination, so before getting into the problems, so how do we go for permutation and what is combination? So in this permutation means number of ways the given things can be arranged is called as permutation. Yeah. For example, I have three members A, B, and C, and I have three seats. Assume it like this. So in this case, I have to arrange these three members in these three seats. In how many ways can they be arranged? So I can fix them as A, B, C, one possible arrangement, and B, C, A, another possible arrangement, and C, A, B, another possible arrangement. So is that only three possible arrangements can be made here? No, guys. So it can be also arranged as A, C, B, and B, A, C, and C, B, A. So in such cases, they can make how many possible arrangements? Six possible arrangements. Yeah. So In this case, what happens is like the number of things is 3 and the number of seats also is like 3. So the possibility that so easily we can able to arrange it and say the number of array possible arrangements is quite very much comfortable. If they were giving number of things as a higher or much more than that, so how do you calculate it? Yeah. So in such cases, we will be using a formula here in calculating permutations. So permutations can be calculated through NPR, where n is the number of given things and where r is the number of things taken. So n is the number of things given and r is the number of things taken. Yeah, and this formula NPR is on the one side we are seeing it. So the formula gets completed like this NPR. So P represents permutations and n factorial divided by n minus r factorial. So I hope you guys know what is a factorial. So factorial, for example, if I'm asking what is the value of 5 factorial, how do you calculate it? So 5 factorial value is given by 5 into 4 into 3 into 2 into 1. Yeah, that is how it is being calculated. And what is the value of 1 factorial? 1 factorial is always 1. And 0 factorial value? So 0 factorial value is also 1. Yeah. So you can ask me, here, sir, fine, everything is here. So, but how can we use this? So look here, I'm trying to use it here. So here the number of things given is what? 3. Number of things to be taken is for 3 charts, 3 members, obviously I need to take it. So in that case, n value becomes 3. So 3 permutation and r value becomes also 3 here. So it is like 3 factorial divided by 3 minus 3 factorial. So in such case, the value is going to be like 3 factorial divided by 0 factorial. So 3 factorial value is like 3 into 2 into 1, which is like 6 divided by 0 factorial value is 1. So final answer is going to be like 6. Yeah. And if you ask like, sir, same 3 persons are there, but only 2 chairs are there. So how many ways they can be arranged? Yeah. So for example, A, B is one arrangement and B A is another arrangement. B C is one arrangement. C B is another arrangement. A C is one arrangement, and C A is another arrangement. So here also the total possibility is like 6 different types of arrangements possible. So how do we go for it? So it is like once again we use the formula. So the number of things given is like 3, and we go for permutations because it is an arrangement, and the number of possible things to be taken is only 2. So it is like r value becomes 2. So it will become 3 factorial divided by 3 minus 2 factorial. So in such case, once again, 3 factorial value is going to be like nothing but 6 divided by 1 factorial value is 1. So once again, the total number of arrangements possible is 6. Yeah. So hope you guys are getting this. So, what is permutation? Permutation is nothing but the number of ways the given things can be arranged is called as permutation. And the formula in which it gives is like NPR is equal to n factorial is equal to n factorial divided by n minus r factorial. Yeah. Hope you guys are clear with this. So, can we go for the other thing? Combinations. Yes, guys. For explaining combinations, also, for example, so what is combination? Combination is nothing but, so it is the number of ways in which the given number of things can form the number of groups. So the number of ways in which the given number of things can form the number of groups. So how many number of groups can that be formed is given by combinations. So for example, three members are there, A, B, and C, and I need to form a group of three members. So how many such groups are possible? So A, B, C, one group is possible, and B, C, A, another group is possible, and C, A, B, another group is possible. Yes, yeah, perfect. But think of the scenario. What is happening here? ABC is a group. I accepted. When I come for B, C, and A, it is not forming a new group. It is the same group, but the arrangement of the persons are different. So it will not be considered as a new group. So this will not be considered. And in the next case also, CAB is also new arrangement. So this is not a new group. So this also will not be counted. So for three members are given, and I need to form a three-member group, means how many such groups are possible? Only one such group is possible. Yes, good evening, Shamruti, Stephen, or if you have any doubts, please let me know. Yeah, or until that, we'll be continuing here. Yeah, so A, B, C. So only one such groups are possible, and for the same three members, if I need to form a two-member group, so two-member group means how many such groups can be formed. So it can be like AB as a group. I can write BA, but BA is just an arrangement, not a group. And next is BC is another group, because like one new person comes or another person exits, then it will form a new different group. And in such case, I can rewrite it as AC also. So how many possible groups can be formed with two members? So it is like three different groups can be formed. Yeah. And if I want to form a one member group, so one member is not a group. So if I want to select one member, so how can I select them? So either A can be selected, or B can be selected, or C can be selected. So three different possible ways is there. Yeah. So combinations is nothing but the number of ways in which the given number of things can form the number of groups, or number of ways they are selecting. Yeah. And the formula to get the calculation is, or like here the values are very low, only 3% are being used. When the count is being increased, so in such cases, how do we go for it? So in such cases, we will be using a formula called as n CR. So once again, N is the number of things given, and R is the number of things taken. And the formula will be like NCR value is equal to N factorial divided by N minus R factorial into R factorial. Yeah, hope you guys are getting this. So if you want to check it, shall we do it? So in the first case, I have three members. So n value becomes 3. And since I want to select three members group, so I'll go for combinations. So in that case, number of things taken is like 3. So I go for it 3C3. So n values are also 3. So it is like 3 factorial divided by 3 minus 3 factorial into 3 factorial. So if you go for it, so this 3 factorial and 3 factorial will get cancelled, and this becomes 0 factorial. So 1 by 0 factorial value is nothing but 1. So only one such group is possible, as we have seen earlier. And in the second case, out of three members, I have to select two members. So it is like 3C2. So it is like 3 factorial divided by 3 minus 2 factorial into 2 factorial. So in that case, it becomes 3 into 2 into 1. And denominator value becomes 1 factorial, which is nothing but 1 into 2 factorial, 2 into 1. So this will get cancelled, and the number of possible arrangements is 3. Or number of possible groups is 3. And in the last case, so it is like three members are there, combinations 3, and the number of members to be selected or number of members to be done is 1. So 3C1 here. So it is like 3 factorial divided by 3 minus 1 factorial into 1 factorial. So it is like 3 factorial divided by 2 factorial, 1 factorial. And if you try to calculate once again, you will end up in 3. Yeah, hope you guys are getting this. So based on this formulas, we'll be calculating the problems on permutations and combinations. So be clear, guys, what is permutation? The number of ways in which the given thing can be arranged. The number of arrangements is given by permutation. Combination, the number of ways in which the given things can be formed, that means grouped, or number of ways you can select the given number of things is said to be as combinations. So in both of these things, so your important point is this formula. So based on this formula, you'll be asked with questions. And moving on for the questions. Yeah, going for the first one. The number of ways a cricket team of 11 can be formed from a 16 members squad. So you have to say whether it is a combination or a permutation process here. Yeah. So if you go for this, the number of ways a cricket team of 11 members to be selected out of 16 members. So in that case, they were saying it as selected. So selection means obviously it is. combination selection process. And how do you go for the calculations? So the given number of things is 16, and we will go for combinations, and number of things to be taken is 11. So 16C11 will be the value, and if you go for the value of it, the value is given by 16 factorial divided by 16 minus 11 factorial into 11 factorial. Yeah, so this will give you the answer for it. And if you want to the value, you can calculate it and find it. And moving on for the next one, the number of ways seven dignitaries can seat themselves in seven chairs kept on the stage. So how many dignitaries are there? So seven dignitaries are there, and can seat themselves in seven chairs. So it is like permutation or combination. The number of ways they can be arranged is being asked. So arrangement is always given through permutation, which is P. So it is like 7p7. And if you go for the calculation, so it is like 7 factorial divided by 7 minus 7 factorial. Yeah. Uh, Going for the next one. The number of ways a panel of four judges can be formed from six retired judges. So in this case, what happens is like four judges to be formed from six retired judges. So what you're doing, is it a permutation question or a combination question? Is it is going to be combinations because we are going to select them. So it is like six members to out total. In that you are going to select four members. So it is like 6C4. And if you are going for the value, so it is like 6 factorial divided by 6 minus 4 factorial into 4 factorial. And moving on for the next one. The number of ways five friends can occupy seven empty chairs in a theater. So is it a permutation question or a combination question? So out of seven chairs, five members have to select their chairs and how many possible ways that can be done. So first, it is going to be a. It is not an arrangement process. It is about the selection process. Sorry, it is like so even they can change their chairs and that will be a different arrangement. So it is like permutation question. So it is like if we go for this, so it can be like 7C5. So it will be like 7 factorial divided by 7 minus 5 factorial into 5 factorial. Yeah, hope you are getting this. And moving on for the next one. The number of ways Raghav can invite three out of seven friends to his house for a party. So seven out of three members, he is going to select it. So selection can be done through combination. So it is like 7C3. So 7 factorial divided by 7 minus 3 factorial into 3 factorial. Sorry for this previous one. So it is like n factorial divided by n minus r factorial only when it is permutation. So when it's combination, so it is like NCR value is like n factorial divided by n minus r factorial into r factorial. So computation of permutation questions. So how the permutations questions can be and few previous questions are also being included in it. So in that first one, so in this question you have to see whether repetition is allowed or not. So for the following questions, identify whether repetition is allowed or not allowed. So how many three-digit numbers can be formed using a single-digit prime number? So I need to form a three-digit number using a single-digit prime number. So what is a single-digit prime number? So single-digit prime numbers are nothing but 2, 3, 5, 7. That's it. And you need to form a three-digit number mean. So it can I write it as triple two or triple three, triple five. So in that case, a repetition is allowed. Yeah. So repetition is allowed for the first case. When I go for the second one, in how many ways can 15 friends sit in 20 chairs in a movie theater? So this repetition is allowed or not is our ultimate question. So in this case, if we go for it, so one friend cannot occupy two chairs at the same time. So in that case, repetition is not allowed. And third question is, in how many ways can four letters be posted in six post boxes? So most of you will be saying this as not allowed. But think of this scenario. I'm trying to post a letter from Delhi to Mumbai, from my house to my friend's house. So from my house, obviously there will be a post box. That letter can be posted in that post box, and Delhi head post office. The same letter will be posted over there, and Mumbai. So once again, the same letter will be posted in that head post office, and my friend's home. The same letter will be posted. Yeah. So in all these cases, if you see it carefully, the same letter is being posted in all the post boxes. So in such case, we can say whenever it is a post box and a letter problem, repetition is allowed for this one. Yeah. So in how many ways can four letters be posted in six post boxes? So in this case, I'm trying to take the six post boxes, and for the first post box, box number one, so I can post all the four letters. Box number two, I can post all the four letters. Box number three, I can post all the four. Box four, box five, and box six. So all the places for four letters can be possibly posted. So in that case, we try to multiply in between these numbers. So you'll be getting it as four. Sorry guys, one small error. So yeah, so repetition is allowed, but in case of the letters to be posted, so what happens is like the first letter one can be posted in all the four boxes, all the six post boxes. Letter two can be posted in all the six post boxes. Letter 3 will be posted in all the six post boxes. Letter 4 can be posted in all the six post boxes. So to get how many possible ways they can be posted, so we'll be multiplying it, and we'll be getting the value as 6 power 4. So how do I remember this thing? Think of it like this. So post box and letter. In this, which one is a constant or stable one? So my post box is the stable one, because since we make mistakes, so which one to be in the power and which one to be as a base. So I'm saying, so post box is always constant. So in that case, number of post boxes will be in the base value. And letter will be always moving from one place to another place, so we can say it as a floating. So that will be in terms of power, which is like floating. So in such case, the number of possible ways that can be done is like the number of boxes will be in the bottom, and the number of letters will be in the power. Yeah. So that is how it is done. So moving on for the next question. In how many ways five friends be seated in three chairs? So you can give your answers for this one. So what I can do is like, for example, first, second, and third chair. So first chair, how many possibilities is there? Out of five friends, if I'm trying to place five friends, so first chair can be placed with five possible chairs, and second one, four possible arrangements, and third one with three possible arrangements. So it is like 5 into 4 into 3 will give me the total number of arrangements for this one. Yeah. So it is like, for this number of ways of filling the first chair is like 5, second chair is 4, and third is like 3. So total number of ways this, so you'll get it as somewhere 60 possible arrangements. But look into this very much carefully. So either I can do it like this, and they were saying like how many ways this five friends can be seated in three chairs. So number of arrangements only they were asking. So number of arrangements means obviously we can do it as permutation question also. So permutation question means out of five members, uh, I want to select three members because for three chairs to be seated. So 5p3 will be my question. And if you try to calculate, so 5 factorial divided by 5 minus 3 factorial, and you will get it as 5 factorial divided by 2 factorial, and you will get the answer for this as 5 into 4 into 3, and your value is going to be somewhat like 60. Yeah, so hope you are getting this. So either you by understanding the question you can able to solve this, or else by logically using permutation content also you can able to solve this question. And try this question. So what they were saying here, what is the maximum number of attempts required to open a, three slot number lock where each slot can have any digits between 0 and 9? So from this, can I say that the first slot can use any digit between 0 and 9? So how many possibilities is there? So it is like 10 possibilities. And second slot can also have like 0 till 9. So they didn't say the repetition should not be allowed. So there will be like once again 10 possible values in terms of second slot, and third slot is like between 0 and 10, 0 and 9, so 10 possible slots. So in such cases it is like 10 into 10 into 10, you will get it as 1000 possibilities. Yeah, hope you are getting this. And moving on for the next one. So, based on the previous content of permutation, please take a look into these questions, and we try to solve each question one by one. So, before that, I'll give you a few minutes time. So, you just take a look into the question and try to answer it in the chats, guys. Yes, guys. Hope you'd have seen this. So, what's the first case? How many five-letter word can be formed using the letter of the word great? If repetition is allowed. So for the first one, so using the letters of the word Great, great. So repetition is allowed. So repetition allowed means so I have how many spaces? Five-letter word I need to form. So in this case, first alphabet, first place can be filled with all the five possible alphabets: G, R, E, A, T, any of the alphabet. And for the second place, also repetition is allowed. That means if I use G in the first place, so same G can be also being used in the second place also. So in such case, once again, it is like five possible arrangements. And in the third place, once again, it is like five possible arrangements, and similarly fourth place it is like five, and fifth place it is like five. So total possible arrangement is like 5 power 5. And in the next case it is like repetition. So second question, so without repetition of alphabet. So in the second case repetition not allowed. So Once again, I need to form a five-letter word. So in the first case, five possible alphabets. And if I go for the second case, it is going to be like if I use G in the first place, I can't use the same letter G over there. So it is like only four possible ways. And in the third place, only three possible ways. In the fourth place, only two. And in the fifth place, it is like only one. So in that case, if we go for multiplying between these values, so either we can say it as 5 factorial, or else if we go for a value, it is going to be like 120. And third question, so such that all the vowels are together. So vowels, so in this given thing, what is vowels being together? So vowels in the given thing is like A and E. So remaining things are said to be as consonants. So consonants are like G, R, and T. So so I need to form a five-letter word. So if I write A here, E should be always written together. So these two places will be always together. If I try to write A here, E should be placed here, which is like together. If I write A here, E should be together. So what I do is, since they vowels always need to be together, so I try to take these two alphabets as a single alphabet. And if I place these three alphabets, that is like consonants G, R, and T separately, also there won't be any issues. So in that case, so I try to take 3 plus 1 alphabets. And since we are going for arrangements, we'll be using permutation. And number of places, so three different places plus, look here, if A is coming here, E should be always here. That means next places should be always engaged. So even in the places also, it is going to be filling it together. So in that case, I also take the number of places as 1. So it will become like 4p4, which is like 4 factorial. And once again, it is not always compulsory that this should be like in the form of AE. It can be also in the form of EA. So within this vowels itself, there is a possibility of uh, rearranging. So within vowels, how many possible ways of arranging? So 2p2. So two alphabets and two places are there. So in that case, 2p2. So which is like two factorial arrangements are possible. So overall, if you are planning like this, so it is like 4 factorial into 2 factorial. So it is going to be like 24 into 2. So you will get 48 such possible words, such that vowels being together. Yeah. So moving on for the next question. So fourth question is that such that vowels are together and consonants also being together. So vowels being together means I try to take all the vowels being together. So in that case, we consider that as 1. And consonants also being together means, so this all the consonants should be also placed as one single alphabet. So it is like plus 1 now, and this is for vowels being together, and this is for consonants being together. Since we are going for number of possible arrangements, we'll be using permutation. And number of places also, it is like 1 plus 1. So in that case, it is like 2p2. So we'll be getting a value as 2 factorial, which is nothing but 2 itself. And within vowels, they can be rearranged. So within and two vowels are there, so it is like 2p2, and it is like 2 factorial arrangements are possible. And within consonants, so three consonants are there, they can be rearranged. So it is like 3p3, so which is like 3 factorial. So 2 into 2 into 6, you will get it as 24 such words possible. Such that vowels and consonants being together. Yeah. So going for the last one and the fifth one. So what you're asking is like no two vowels are together. So no two vowels being together means, so how can that be possibly arranged? So once again, you have to take five alphabets, sorry, five places. So if I write A, so E cannot be placed in this position. So E can be placed here, or E can be placed here, or E can be placed here. And if I try to write A here, so the possibility of E not getting is like this cannot be placed, and this place also cannot be placed. So E here and E here. Yeah. So that means I have lots of opportunities for placing this guys in different varieties and getting different possible arrangements. So what should I do for here to get no vowels being together? So how do I go for it? So instead of thinking of what are all the possible ways of making this arrangements of no vowels being together, so from yes, guys. So in this case, if I go for it, so it is going to be like this. So no vowels being together. So it is like this. So total number of arrangements. So once again we get a confusion that which one should we go for? So should I go for without a repetition or with repetition? So repetition being allowed, or so this 5 power 5, or like a repetition not allowed 5 factorial value. So it is always like this. So we'll always go for whenever they didn't give any Yeah, guys, sorry for it. So I think because of some technical issues, the screen has been started missing. Maybe because of network issues or something. Sorry for it. So I think now this you can able to view my screens clearly now. Yeah, hope you are getting this last problem. So no vowels being together means I try to take the total number of possible arrangements, and from that I try to go for this vowels being together be subtracted, so that I'll get vowels being not together. Yeah. So from that total number of arrangement is like 120, and from that minus 48, so it is going to be like 72 possible arrangements. So this will be the answer for it. And if you have any doubts, you can go for it, or else I think we can move on for next one, guys. So moving on for the next question. So try to answer this question, guys. Please take a look into this. So how do we answer this question? Yeah. So to answer this question, so what they are asking, make use of five digits 0, 2, 6, 7, and 9. So how many four-digit numbers can you make without a repetition of the digits? So without repetition of the digits, they have asked. So in that case, so how many digits are there? So it is like five possible digits are there, and I need to form a four-digit number. But be clear, guys. In a four-digit number, for example, this is thousands place, this is hundreds place, and tens and unit digit. So in a thousands place, be careful in this. Zero is being given to you. So without zero means I can say it as five possible ways, four possible ways for this, and three, two. But in this case, what happens is like I can't use zero in the thousands place. So how many possible ways for this thousands digit? So only four possible ways. And when I come for other three values, so I can use zero in terms of hundreds, so that it will form a four-digit number. So in that case, so zero and three more digits, because without repetition, so you have to consider. So three more digits are left out. So totally four possible digits in terms of hundreds place, and three possible digits in terms of tens place, and two possible digits in terms of unit digit. So it is like 4 into 4 into 3 into 2. So totally 96 such numbers can be formed. Yeah. And moving on for the next question. How many four-digit even numbers can be formed using this digits? So even numbers to be formed. So 0, 2, 6, 7, and 9 are the digits. So in this case, I need to form a four-digit number. And how can I say this number should be an even number? Can be an even number. Yeah. So if I get the last digit as an even number, so I can say that complete value is going to be an even number. Yes. Yeah. So what are the possible ways? So 0 to 6 from the given numbers of list of given numbers 0, 2, 6, 7, and 9. So from that I have to pick means 0, 2, and 6 days, and remaining places I have to fill it. So three possible ways. So how many possible values here? 4, 3, 2. Is it? So is there a possibility of remaining four possible values? Think of this. If I try to place 0 here in the unit digit, so there is four possible ways of placing thousand digits, thousands place. But if I try to fill it with 2 here in the unit digit, so 0 cannot be placed here. So how many possible values? Three possible values only I can place, remaining three values. Yeah. So should I keep it as three or four? That itself a big confusion, right? So in such scenarios, what we do is we try to split this content. So how do we split it? So 0 being at the last digit, one condition, or any other value being at the last digit. So which is like 2 or 6. So in such case, so 0 being the last digit means, so how many possible values? So only one possible value for this. And for thousands place, you'll be having four remaining possible values. And for 10,000, sorry, hundreds place, it is like three. And for tens, it is like two. So 4 into 3 into 2 into 1. So 24 possible arrangements here. And here in this case, so unit digit being at 2 or 6, so you'll be having like two possible values. And but you can't use 0 in terms of what 10,000s value, thousands place. So only three possible remaining values can be used here. And but in terms of hundreds place, so once again three possible values can be placed. And here it is like two possible values. So totally 36 possible values can be placed. So either this can happen, or I already mentioned, so or else being 2 and 6 at the last digit can be possible. So overall we try to add this places, so it is like how it's been done. Yeah, hope you guys are getting this. And moving on for the next one, next question. So, how many four-digit numbers divisible by 4 can you form? So, when can you say a number is divisible by 4? So, from the given numbers of 0, 2, 6, 7, and 9, so I can say I need to form a four-digit number. When can you say that number is divisible by 4? So, using the divisibility rule of 4, we can say that if the last two digits of the given number is divisible by 4, then the complete number is divisible by 4. So what are the possibilities from the given value 0, 2, 6, 7, 9, such that it is divisible by 4? So I have to go for the combinations. Is it like 0, 2 possible? 0, 2 is divisible by 4? No, not. 0, 6 or any other value? No. So what are the possible values? So if I go for this, so it is like 20 is divisible by 4, 60 is divisible by 4, 72, 76, 92, 96. So these are the possible values in which it is divisible. So here also what I try to do is like I try to split it as two things, with zero at its last and with non-zero at its last. Yeah. So because to avoid confusions, so zero is already been used, one more digit has been used means, so already you have two possible values for this last two digits, and only thing you have to fill here is like this thousands place and hundreds place. So thousands place, how many possible values are there? So I have left out with three possible values in thousands place, and two possible values in terms of hundreds place. So it is like 3 into 2 into 2 is the value. So it can be like 12 such values are possible here. And in the previous case, 72, 76, 92, and 96. So four possible values are possible in terms of last two digits, but we are going for the previous digits, which is like thousands place and hundreds place. So in such case, we'll be like, so in thousands place we can't able to use zero. So only two more digits are possible, and when it comes to hundreds place, zero can also be used. So once again, two more digits are possible. So 2 into combining with this four digits. So you can get it as 16 such digits is possible. So overall, if you try to take, so you will get it as 28 as your value. That means 28 such numbers are possible such that the given number is divisible by 4 at last. So answer for this is 28. And for the previous one it is like 60. So hope you guys don't have any doubts in this. And moving on for the next one. Yeah, try to read the question and try to answer this one, and I give you a few minutes time to understand and solve it. Yes, guys. Hopefully you would have read it and maybe you would have solved it. So going for this. So in how many ways can three boys and three girls sit in six chairs? So if that is the condition, so three boys and three girls are there. So so totally six members are there and six chairs are there. So I would have used permutation and I have mentioned the answer as 6 factorial as the answer. But the problem is not like that. They have given something different. So they have given two more questions extending that. So if no two boys should sit together, so then how can that be done? So for example, six chairs. So for the first question, no two boys being sit together, how can that be arranged? So out of three boys and three girls, no two boys should sit together. So how can I arrange them? So one boy in this place and one girl, boy, girl, boy, girl. Is it possible? Yes. So is it only one arrangement? No, guys. Look here. There is no compulsion that the first boy should sit here, second boy should sit here, third boy should sit here. Within boys itself, they can give different possible arrangements. So within boys itself, they can arrange it like three boys, three places are for boys, and three places and so totally it is like 3p3, so it is like 3 factorial ways they can be arranged. Similarly within girls also it is like three girls are there and three places for girls, so within them also if we try to rearrange it is like three factorial. So it is like 3 factorial into 3 factorial, you will get it as 36 possible arrangements. Hope you are getting this. Is this the only possible way of arranging these guys? Is it so? It is not compulsory that the arrangement should always start with a boy. So it can be like girl, boy, girl, boy, girl, boy also. So within the boys, if we are trying to rearrange it, so it can be like 3 factorial once again into 3 factorial. So you'll get it as 36 possible ways. And they have only mentioned that no two boys should sit together. So in that case, boy, girl, girl, boy, girl, boy. So there is no possibility that no two boys are being seated together. So here also 3 factorial, you will get it as 36. And is that the only possibility? No. Girl, girl, boy. So that was like once again 36 possible arrangements. arrangements for this. So, is there any other way that such that no two boys being sit together? No ways or four 140. So, how can I arrange this Yes, guys. Sorry for the trouble. So maybe because of some network issues or something. So sorry for it. Yeah. Hope my screen is visible now. So this is the question. So how many four-letter words can be formed using all the letters of the word test? So most of you will be saying it as, sir, four letters are being used. So we can use permutation because like different arrangements are there. So it is like permutation, and we'll be getting it as four possible places. So it can be like 4 factorial as the answer. But the problem is, think of this. I am trying to write test, and I am trying to once again write it as same test. Is it different arrangement or same arrangement? Both the words are same. So words are same. But whenever I go in terms of arrangements, is it same arrangement? Think of this scenario, guys. First T and second T and first T. So the arrangement wise, it is different. And when a permutation is being used, so permutation only gives me arrangement. So it counts in different arrangements. So and it gives words this both test as different words. But when I count it as words, So how many four-letter words can be formed? So number of words means, so this test and test are same. So this is not different test. So in that case, I have to cancel the second repeated word test. So how do I go for it? So in such case, what we can do is like, why this word, repeated word is being formed? Because of this two t's used here. Yeah. So in such case, because of the two t's only it is getting repeated, means we try to divide this given number or this final number by 2 factorial because of the words formed by that 2t. So it is like 4 factorial divided by 2. So I'll get it as 24 divided by 2. So value is 12 such words can be formed without repetition, or 12 new words can be formed. And similarly, try for this one, guys. So, how many words can be formed using all the letters of the word elephant? Try to answer it fast in the chats. So, if I go for it, elephant, so totally how many alphabets? So, it is like 4 plus 4, it is like 8 alphabets are there, and 8 places. So, 8p8, we'll get it as 8 factorial as the value. And how many e is being used? So it is like two e's are being used. Because of that, the word can be repeated. So to cancel that word, so we'll be dividing it by 2 factorial. So 8 factorial by 2 factorial is going to be your answer for this one. And moving on for the next one. So in how many ways can 3 red balls and 2 blue balls be arranged in a straight line? Think of how many possible ways. Yeah. So how many red balls? Three red balls and two blue balls be arranged in straight line. So three red balls means red ball one, red ball two, and red ball three. Uh, Even if I arrange it as red ball two, red ball one, and red ball three, so the arrangement is going to be different. But when I see it from outside, it is all the three are going to be same red color. No one can able to find that. But how many different arrangements only they have asked? So in such case, this second arrangement is going to be a repeated arrangement, so this has to be cancelled. So in that case, same logic will be formed. So totally five balls and five arrangements or five places. So it is like five factorial arrangements is there. So divide that by how many three red, because of this three red balls we are getting repeated arrangement, so we cancel it by 3 factorial. Because of this two blue balls we are getting this arrangement being uh, changed. So in that case 2 factorial. So this is the answer for the question. So how many possible straight line arrangements can be made is like 5 factorial divided by 3 factorial into 2 factorial. So hope you guys are getting this. And try to answer this question fast. So, in how many ways can file letter be posted in 4 post boxes? So, once again, how many ways? So whenever it is a letter problem, I have already mentioned you guys, the number of boxes will be always in the base and the number of letters will be in the power. So in such case, the answer for this is 4 power 5 because 4 is the number of post boxes. 4 post boxes are being used here. So this is your answer for this one. Yep. Hope you are getting this. And moving on for the next one. So computation of combination problems. Yeah. Try to read the question, understand it, and answer it in the chats. I'll give you a minute to do it. Yes, guys. Hope you have seen this. So, in how many ways can you form a cricket team of 11 comprising of 6 batsmen and 5 bowlers from a square of 16? That is like 8 batsmen and 8 bowlers. So, if you're going for this, first let us select the number of ways in which a batsman be selected. So they have just mentioned like out of 16 members, I have to select 11 members. I would have gone like 16C11, but they were so much specific that so they need 6 batsmen and 5 bowlers. So in such case, what we can do is like a number of ways selecting batsman is so totally 8 batsmen are there, and I need 6 batsmen. So 8C6 is going to be your answer for this one. And in the other case, so how many number of ways of selecting bowlers? So totally 8 bowlers are there, and I need 5 bowlers. So 8C5 is going to be your answer, which is like 8 factorial divided by 8 minus 6 factorial into 6 factorial. And in the other case, 8 factorial divided by 8 minus 5 factorial into 5 factorial. And to form a team, so you obviously need batsman and bowler. So it is like 8C6 ways I can select a batsman, and 8C5 I can select the bowlers. So within them, we'll try to multiply the values, and based on that, we try to answer it. So that is how you will get the answer for this one, guys. So hope you guys are getting this. And moving on for the next one. Try to answer this one fast. So this is quite easy problem. So once you understand it, you can easily able to answer this one. This guy is in how many ways can you form a committee of four from five men and three women? So totally they have asked like four members from five men and three women. So in the first case, if the committee comprises of two men and two women, so two men and two women. So how do I form it? So out of five men, I need two men. So it is going to be a selection process. So in terms of selection process, we will be using combinations. And for women, so it is going to be like out of three women, we are going to select two women. So it is that is how we are going to select the four members. So 5C2 into 3C2 is going to be your answer for this one. And moving on for the second one, the committee has at least two men. So what does mean by this at least two men? What is the meaning of this at least two men? So in this case, at least two men. So minimum value is two men. So minimum two men means if I go for two men, uh, in the committee of four members list, so remaining two are going to be women. So that is the one case. And other possible cases like minimum only they have mentioned. So there is a possibility that more than two men are also possible. So in such case, three men's if comes, so one women will be there. And in the last case, all the four can be male because that is also not restricted. So zero women. So in such case, so it was like out of five, two members you have to take it. Out of three women's, you are going to take two in the first case. And out of five, it is like three members. Out of three, it is going to be one member. And out of five, it is four. And this is zero. Where should I add it? So that is a major question, or how do we go for it? So in this case, what happens is so between this two men and two women, they form a committee of four members. So overall, between them, we try to multiply between these two values. And is once again here. here also they need to form a 4 members list. So between them we try to multiply, and either this can happen or this can happen, or this can happen. So in such cases we try to add between the values. Yeah. So third question is, the committee has no more than two women. So what is mean by no more than two women? So no more than two women means the maximum number is fine. So we start with two. So in this case, maximum number is fine. So we start possible. Yeah. So is then in that case, and yeah, so women and so we do it once again. So if you have in doubts, you can. So the answer next one. So one particular member always has to be selected. So how that can be done? So one particular member has always need to be selected. For that particular member, or they has to be selected means totally I have to select only 4 members. So out of 4 members, one member is always selected. So that person, one single person will be kept outside of it. For remaining 3 persons only, we are going to do the selection process. So it is like out of remaining how much? So 5 men and 3 women are there. So totally 8 members should have been initially there, but one member is already been selected means so remaining will be like 7 members only will be there. Out of them, I have to select 3. So it is like 7C3 is going to be your value. So it is like 1 into 7C3 is your answer. So the answer is nothing but same 7C3. If you try to calculate the value, you will get it. And moving on for the next one, one particular member should never be selected. So how do I go for it? One particular member should never be selected. In that case, so out of 4 members, I have to select one member. I never want them. So totally 8 members are there, but one member is not going to be selected. Means so only we are going to get 7 members. Out of that, 4 members if we are selecting. So the 7C4 is your answer for this one. So these are the answers in which we are going to have. And moving on for the next one. Try to answer this one fast, guys. So this is also similar to the previous one, and it is going to be very much easier. I'll give you a minute to answer it. Yes, guys. So from six friends, in how many ways can you select three friends to your house for a party? So out of six friends, I have to select three friends. Means so it is going to be like so selection process. So selection means once again we'll be going for combination. So which is like out of six members, I have to select three. So 6C3 is going to be your answer for this one. And moving for the second question, one or more friends to your house for a party. So one or more friends means so how many ways I can select one friend. So out of six friend, I have to select one means 61. So either this can happen or two friends, so it is like 6C2, or three friends 6C3, or 6C4, four friends, or 6C5 for five friends, or 6C6 for six friends. But you know what is this R? So R can be used in terms of calculations. So in that case, or should have to be rearranged. So or has to be rearranged with plus. So 61 plus 62 plus 63 plus 64 and 65. So because as we have seen in the basic fundamentals of counting principle itself, R means we will be adding it. And in the last case, at least two friends to your house for a party. So two friends means two is possible, or three members are possible, or four, or five, or six. So in that case, it is going to be like 6C2, 6C3, 6C4, 6C5, and 6C6. So we try to add it. So it is going to be once again our condition. Yeah. Hope you guys are getting this, and it's going to be like we are end of combinations. So we are done with the content. So if you have any doubts, you can place your doubts and queries in the feedbacks or in your chats, so that I can come up with the queries with a solution in the upcoming sessions. Thank you guys. Once again, thank you all for and have a great day.